our lesson on Tuesday, I introduced you to differentiation or finding the gradient at a point using the concept of first principles, because this is always our very first question in calculus. Once we've done that question in calculus, when they require us to differentiate again, we're always going to be using rules. So you only use the first principles method when the question asks you to. Otherwise, if you are required to differentiate, you need to use the rules. And we're going to go through those rules today and practice a few things. But before we get started on that, it's always important for us to check our prior knowledge. Okay. Now, you're going to understand why in a little while. But before we can start applying the rules for differentiation, we need to know something about exponents and surds. Okay. So I just want to go through that with you. Please take screenshots. It's going to help. All right. What I want to try and encourage here is that when they give you a term, you need to be able to write your term in the following format. So I don't know if you remember from grade 8 when you first learned about algebraic terms, but we always write terms sign followed by our number, which is our coefficient. Let's just scooch over a little bit here. Followed by our variable. And on our variable, we may have an exponent. Okay, so let's just run through some different examples just to refresh your memories, because we need to be able to do this in order to apply our rules for differentiation. Okay, so if they give us, let's just make this a little bit bigger for you guys. I don't know if you're struggling to see it or not, but we'll just make it a little bit bigger. Okay, so if they give you something like the first example over here, so you've got x over 9, or sorry, x to the power of 9 over 5, okay? That means 1 over 5x to the power of 9. Okay, so there's an invisible 1 sitting over here. So we need to be able to separate it so that we can see the sign we know is positive. The number in this case is 1/5. Our variable is x, and we can see our exponent. Our negative exponents. So if one of the things that we need to be able to do when we differentiate is remove divide lines like the one over here. So what we can do is we can take what was in the denominator into the numerator, provided we change the sign of the exponent. Okay, so 3 over x squared can be written as 3x to the power of -2, and that means that the x is now in the numerator. Okay, another example, so if we had a fraction, so if they gave us 2 over 3x to the power of 4, what we would be required to do is take this part over here into the numerator. So again, our coefficient is going to be 2 over 3. Taking our x into the numerator, changing its sign, that means it can be written as 2 over 3x to the power of -4. Okay, so that's just a reminder for you about negative exponents. What if they actually expect us to do a small operation? So in other words, they give us 8 over, and then they put 3x in brackets, and they decide they want us to square it. Okay, so the first thing that, sorry, please can you mute? So the first thing that we would need to do is we would need to square 3x. Okay, so when we square 3x, it's going to become 9x squared. Again, we can separate our coefficient from our variable and write it as 8 over 9. And if we want to write our variable in the numerator, we can do it like that, and we can change the sign of our exponent. Okay, what happens when we're working with roots? So what I remind my classes when I teach them, for example, is if I have something like x squared and I want to take the cube root of that, all right, I can write this without the root as a rational exponent. I would write it as x to the power of 2 over 3. Okay, how do I remember what goes at the bottom. So this is a little trick to help you. The guy at the bottom gets kicked to the outside of the party. Okay, the guy at the bottom gets kicked to the outside of the party. All right, so if you had to take the cube root of x squared, you could write that with a rational exponent and write it as x to the power of 2 over 3. So now let's go and have a look at the example that we've got over here. We've got 5 over the cube root of x squared. So what we want to do is we want to get rid of the divide line. We want to get rid of the root as well. So we can take this into the numerator and change the sign of our exponent. Okay, and that's why we've written it as 5x to the power of negative 2 over 3. Okay, so sign number variable with our exponent. Okay, in this particular question over here, there's not really much that we can do with the 6, right? It would remain as the cube root of 6, and then we can rationalize our exponent and write it as x to the power of 5 over 3. Are there any questions? Leanne, log out and log back in again if you can't see the screen. Any questions, anybody? Is everybody all right with that? Just some basics before we start talking about the rules. No, are we all good? I'm good, okay. Cool boy Chepo, thank you. Mihlali. All right, so I'm going to move on then. So just a little bit of practice with you. We don't have to do all of these. All right, Salma, welcome, no problem. Okay, we're just going to do a couple of them. All right, so I'd like some volunteers. Anyone who's feeling brave, we'd love to hear your voices. I'd like somebody to offer to do A for me, please. Who would like to do A? And Hlantla, go for it. Thank you. So you can unmute yourself, Hlantla, and then we can hear your beautiful voice.
Afternoon, ma'am.
Afternoon, how are you?
I'm good, and you, ma'am?
I'm fine, thank you. Okay, so in Hlantla, you're going to write this in the form sign number variable with the exponent. Okay, go for it.
Okay, is it 1 over 2?
Mm-hmm.
And then times x to the negative 3.
Beautiful. Yes, 100%. 100%. Perfect. Okay, so there you go. You've got it. Sign number variable. Fantastic. Well done. Brilliant. I'm so pleased. Okay, good job. All right. Now I would like another volunteer, please. Who would like to do F for us? Question F. Question F, please. Who would like to do question F? Mihlali. Okay, go for it, Mihlali. Tell me what to write here, please.
Hi, ma'am.
Hi, Mihlali.
I think it's 3
Yes.
multiplied by x to the exponent negative 3 over 4.
Beautiful. Oh, you're a star. Wonderful. 100%. Fantastic. All right. Very, very nice. And then one last one. Excuse me. We'll call it a day after this, and then we'll move on. Question G. Who would like to volunteer to do that one, please? Come, we love hearing your voices. Chiamo, go for it.
Good evening, ma'am.
Good evening, Chiamo.
At G, it is x.
X. Good.
To the power of negative 8 over 2.
Excellent. All right. Now, can you simplify your exponent?
I think so, ma'am.
Okay. Also, just hang on a second. you've taken it from the denominator to the numerator, so don't forget to change its sign. Okay, so it needs to be positive, all right? But you're on the right track. So 8 over 2 means 8 divided by 2, so you can write that as x to the power of? There we go. Okay, positive 4. Good job, Chiamo. Well done. Okay, and Palesa, well done on noticing that it was supposed to be positive and not negative. Okay, so if something is negative, if there is a base and it's negative in the denominator, so for example, if I've got x to the power of negative 3 in the denominator, I could write that as x to the power of positive 3 in the numerator. Okay. So you don't need to worry about negative exponents now. You're not expected to write answers with positive exponents anymore. We do that to you in grade 9, 10, and 11. And then all of a sudden in grade 12, when we do calculus, we can leave our answers with negative exponents. Well, that's leaving our answers. Sometimes, like here, obviously we wouldn't have left that with a negative exponent because it's gone to the numerator. All right, good job, everybody. Let's move on and go and have a look at notation. Okay, so now notation in calculus is very, very important. You get penalized at the end of the year if your notation is incorrect. Okay, so there are sort of three, it says here there are 4 different notations you're expected to know. The 3 most common ones are the ones that I'm going to go through with you, okay? But there are various ways to represent a function and its derivative, all right? So if they give you the function in f of x notation, so for example, as f of x equals 5x squared plus 3x, when you write the derivative, you have to show that you have taken the derivative by writing f prime x. So it's not just what you're writing, it's not just the maths, it's the notation and how you're writing it that's super important. So we're going to practice this a little bit more this evening. If they give you the function in the form y equals, then when you take the derivative, you write dy over dx, the derivative of y with respect to x. That's what it means, the derivative of y with respect to x. I'll just write that here for you. So the derivative of y with respect to x. Okay, and then the last common way in which we are given functional, derivative notation is as follows. Okay, so what they do is they write dx with capital letter, well, capital D is small subscript x, and then they put the function into square brackets. Okay, you will keep the d and the x and the square brackets until you are ready to take the derivative. And then when you write your derivative, you drop the d, x, and the square bracket, and you just write equal. So I'm going to show you all of this, how this works through examples that I'm getting to. I just wanted to go through the notation first. Okay, so for f of x, when we take the derivative, we write f prime x. If we are given a function in the form y equals, we write the derivative as dy over dx. And if they give us our function statement as dx and then in square brackets, when we take the derivative, we drop the dx, we drop the square brackets, and we write an equal sign. Okay, but I'm going to show you all of this through some examples. Okay, so in each step of the solving process, keep the original function notation you are given until you actually determine the derivative. Okay, if you don't do that, they are going to penalize you. All right, and I'm going to show you, as I said, through the examples what I mean. Okay, now let's get to the actual rules. There really are only 2 rules that you absolutely need to know. Okay, so screenshots. Sorry, I know I'm going through this fairly quickly. Oh, are there any questions? Sorry, I should have asked. Any questions?
And take screenshots.
Yes, and take
you.
screenshots.
Yeah.
It will help you. Any questions so far, Matrix? Okay, I'll take your silence to mean no. And we'll keep going. Hang on a second. No. Okay. All right. Perfect. Okay. So the two rules that you really need to know. The first one, the derivative of any constant always equals 0. Right? Now, the reason for that is because if you have a function y equals 3, think about that. If I was going to draw that on the Cartesian plane, what would it look like? If I had to draw y equals 3 on the Cartesian plane, what would I be drawing, Matrix? Can anybody tell me? What am I drawing? If I draw the line y equals 3 onto a set of axes, what does it mean? And Nhlanhla, go for it.
Ma'am, it would be a line parallel to the x-axis at y3.
Exactly. Beautifully put. I couldn't have said it better. So there you go. There is the straight line that Nhlanhla was talking about. Okay, parallel to the x-axis. And at this point over here, this is where y would be equal to 3. What is the gradient of this line? What is the gradient of the blue line, Matrix? Okay, so remember, gradient means walking uphill or walking downhill. Okay, it would be 0. Okay, so the gradient of any straight line would be 0. Okay, so if we have got a function like y equals 3 or f of x equals 3, and they ask us to take the derivative, we would state that f prime x would be equal to 0 because the gradient of any horizontal line is 0. Okay, so that's why if k is a constant real number, then your derivative of any constant will always be 0. Okay, because the gradient of any line parallel to the x-axis is always 0. Okay, and there again, can you see how it was written, right? If your function statement is f of x equals 0, you would then only write f prime x where you have taken the derivative. Okay, so that's this line over here when your derivative was equal to 0. Okay, so that's rule number 1. The derivative of any constant is always 0. The second rule is called the power rule. Okay, and this is the shortcut on first principles. Okay, so this is how it works. If they give us a rule like f of x equals x to the, writing the exponent instead of the variable, sorry, beg your pardon. F of x equals x to the power of 10. This is how the power rule works. When we take the derivative, we are multiplying the exponent by the coefficient. Now, in this case, our coefficient is an invisible +1. Okay? We are ready to take the derivative because each term, what's the only term here, has been written sign number variable. So we are going to write the derivative of y with respect to x. I'm going to multiply 10 and 1 together and get 10. And then I'm going to take 1 away from my exponent. Okay, so I'm going to end up with an exponent of 9. That expression will allow me to calculate the gradient at any point on the curve, provided I know the x coordinate at that point. Yes, so they could. They could. So you're going to see where we use this a little bit later on, because what we're doing now, we're not really doing questions that they'll give you in tests and exams. This is just the background information. So when we get to those sorts of questions that they would give us in tests and exams, I'll point them out to you. Okay, so our power rule, again, I'll just write it on the side over here, what we are doing. Okay, so the first thing that we are doing is we are multiplying. So number 1, we are multiplying our exponent with our coefficient? After we have multiplied our exponent with our coefficient, we subtract 1 from our exponent. Okay, that's the power rule. Okay, that's how we determine the derivative. Okay, any questions? And I'm going to move on. Any questions,
Ask
Matrix?
your questions or forever hold your peace, guys. Do you understand? Do you not understand? Oh, Naledi has a question.
Okay, now lady, go for it.
Afternoon, ma'am.
Afternoon.
Ma'am, with the power rule, does this only apply when x is 1?
No, so x can be so the number in front of the x can be anything. So for example, let's say I get given f of x equals 3 over 2x to the power of 4. Okay, I'm going to do this as an example with you now. This is what I would do. I can see that my function statement, f of x, is written as sign, number, variable. So I'm ready to apply my power rule to this term. So what I'm going to do is I'm going to take the derivative, excuse me, and I'm going to multiply 4 with 3 over 2. When I multiply 4 and 3 over 2, you can do that on your calculator, I would end up with 6. 4 times 3 over 2 is 6. I'm going to write down my variable, and then I'm going to take 1 away from my exponent, and I would end up with that. Okay, so it's not just for coefficients that are 1, it's for any coefficient, positive or negative. Okay, Naledi? All right, good stuff. Okay, so if they gave you this one, f of x equals 3x to the power of 6, and they ask you to determine the derivative, can someone tell me what you think we would do here? How would we write the derivative? Any brave person wanting to offer an answer?
We can do this, Matrix.
You can.
There we go,
William,
yeah.
cool. William, go for it. What would you do?
You would write 3 times 6.
Okay. So set it out the right way. Go f prime x equals 3 times 6 would give us?
That would give us, I think, 18.
Excellent. X to the power of?
6 minus 1, which is 5.
Beautiful. Perfect. Okay, 100%. There you go. Lovely. Let's do one more. Okay, who wants to do this one? Any brave person want to try this question? Leanne, awesome. Go for it, Leanne. What would you write?
Ma'am, all right. G prime x is equal to 1 over 3 x cubed.
Okay, now, I'm so glad you said that, Leanne, okay? Because this is exactly the mistake that matric students make, all right? You are not applying the power rule, so you cannot write G prime x. Okay, it's only when you apply the power rule. So when you are separating the coefficient from the variable, you have to still write it as G of x. Okay, so that is your first step. Okay, now you can apply your power rule. Now you will write G prime x. Okay, take over from there, Leanne. What would be the next thing that we would write?
Then, ma'am, I'll say 1 over 3 times 3.
Good.
Which is 1.
Mm-hmm.
And then x3 minus to the power 3 minus 1 will be 2. Therefore, we'll have our end result as x squared.
Lovely. Beautiful. Okay. Very, very nice. So I'm going to say that again, all right, because it's a very, very common mistake. And I'm very glad that you said that, Leanne. Okay. You are not writing the derivative. If you only write G prime or F prime when you are applying the power rule. If you're not applying the power rule and you're separating coefficients from variables, you don't write G prime X, okay, because you are not differentiating. Okay. All right. Okay, so here's another one that requires a little bit of manipulation before we can find the derivative. Does anybody want to tell me what it is that I need to do here first? Anybody else? I'm so glad about your participation tonight, Matrix. We love hearing your voice. So, Palesa, let me just read what you written. No, Palesa, it would be x to the power of 2. Okay, so the x is on this, the square is on the x. Okay, who's got a hand up here? William, you have a hand up again. Go for it, William. What would you write?
Ma'am, I would write the derivative of y or dy over dx.
Okay, before you can do that, William, you've got to do something else. You can't write dy over dx just yet.
Do you put 3 over 2 times x to the power of -4?
That's it.
Well
Okay.
done, William.
That's it. Okay, now you're going to write dy over dx because you're applying your power rule. Go for it. So we're writing
dy over dx equals to 3 over 2 times minus.
Correct. So 3 over 2 times -4. I'm just going to write it in here. X to the power of?
X to the power of -4 minus 1.
Lovely. Okay, and then let's just tidy that up a little bit. Okay, so what would you have when you said 3 over 2 times -4? You'd end up with a coefficient of?
-6.
Excellent. X to the power of?
-5.
Beautiful. Well done, William. Lovely, 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 lovely. Okay, good. Good job, everybody. Okay. Now here's a difficult one. Or is it? Just depends on how well we understand. Okay. First of all, could you redo that example? Okay, this one over here. So first of all, you had to separate the 3 over 2 from the variable, put the variable in the numerator because it was x to the power of 4 at the bottom. It becomes x to the power of -4 at the top. You are still writing y, okay, because you have not differentiated. You've just manipulated your expression to get sign, number, variable with your exponent. Now you are deriving by multiplying the exponent with the coefficient and then taking 1 away from the exponent. That's how we end up with -6x to the power of -5. Okay. All right, well done, everybody. Okay, so let's have a look at this one. I think what I'll do is I'll do this one as an example for you guys because this is a little bit more difficult. Again, I'm not ready to derive. When I want to derive, before deriving, okay, I have to, number one, remove divide lines. Number two, I have to remove roots. Number three, I have to remove brackets. Okay, so those 3 things have got to go before I am allowed to derive. Okay, so that means I cannot drop or change my notation until I've done those 3 things. Okay, here I don't need to remove brackets. I need to remove divide lines and roots. So this is what I will write, okay? I'm allowed to write equals dx and then my square bracket, okay? I'm going to leave the 2 at the top, all right? The cube root of 27 is 3. The cube root of x to the power of 9, I would divide 9 by 3. So that's going to give me x to the power of 3. Again, I'm not ready to derive, so I'm not changing my notation. Now I'm going to separate my coefficient from my variable, put my variable in the numerator, and change the sign of my exponent. Now I'm ready to derive. I've gone sign, number, variable with my exponent. Okay, now I can derive. I'm going to drop my dx and my square brackets, and I'm only writing equals. Now I'm applying the power rule because I'm deriving. A positive times a negative is a negative. 2/3 times 3 is 2. Write down my x and take 1 away from my exponent. Okay, that's exactly it. Well done, Ayanda. Perfect. Nawazi, what did you write? Yes, good job. Okay, so Mithlali, what didn't you understand? Can you be a little bit more specific? Screenshots, everybody else? Yes, Leanne, quite right. The first step. Okay, so this is a cube root. So the cube root of 27 is 3. When I remove a radical, I've got to divide my exponent by the root. Remember, we were talking about that up here. Okay, so like this one here, 3 over the 4th root of x to the power of 3. Excuse me. Okay, can you see how I have divided my exponent by the root? I've written it with a rational exponent. Okay. All right, so it's exactly the same idea. I've got to do that first. I've got to get rid of the root and write things with rational exponents. Or in this case over here, it's not rational because 9 is divisible by 3. Okay. Yes, William, you do. You do. You don't have to rewrite it with a positive exponent. Okay, and you'll still get full marks. Okay, so that's nice. At least we don't have to go and worry about that extra step. So as I was saying, grade 9, 10, 11, we make you write everything with positive exponents, and then in calculus and matric, you're allowed to leave things with negative exponents. Okay, all right. So everybody, we are removing divide lines, roots, and brackets before deriving. And we do not write that we have derived if we haven't actually applied the power rule. Okay, so we need to be careful of this. Otherwise, we're going to suffer penalties in our tests and exams. Okay, so what I would like you to do, I don't want you to worry about those ones. Okay, I want you guys to have a look at the questions that I have put over here. So A, B, and C, they are very easy. We should be able to whip through these quickly. When you're done, say done, and then we can go through the answers. Okay, so I'd like you to try all 3, please. Pay attention to your notation as well as to what you are writing in terms of the maths. Okay, go for it. Any questions, please ask Yolanda and I.
Your time start now. I hate when they do that in the exam. Like,
Yeah,
your
absolutely.
time start now.
I
And then
know,
now you
all
need to
that
start.
pressure. Absolutely.
All right, guys, let's do this. Try your best, and we are here if you get stuck.
Absolutely. So these ones are nice, easy ones. They shouldn't be causing you too much stress and worry. Cool. Someone's already done. Oh, lovely. All right. So a lot of you are done already. Absolutely. These were very, very easy. Excellent. Okay. Who wants to do A for us? Any takers? Chiamo, go for it. What did you write for A?
At A, ma'am, I wrote F what's
F
the
prime.
the
So it's called prime. F prime.
yes, ma'am, yes, ma'am. Yes,
Mm-hmm.
ma'am. F prime is equal to 6x to the power of 5.
Beautiful. 100%. Well done. Good
Well
stuff.
done. Yep.
Nice.
Thank
Okay, who's going to do B for us? Who's going to do B? Mihlali, go for it, Mihlali.
It's dy over dx equals 32x cubed.
Beautiful. Fantastic. 100%. You are on fire. Okay, next one, last one. Who wants to do this one for us? Amahle, would you like to do this one?
Yes, please. Good evening, ma'am.
Good evening, Amahle.
The answer would be equals to negative 35x to the power of 4.
Fantastic. Okay, smoking hot, guys. Well done. All right, so screenshots, everybody. And let's move on to something just a little bit more challenging. Okay, got it. Awesome. I'm so glad. Okay. Here are some slightly more difficult questions. All right, what we are going to try, okay, is, again, I don't want you guys to worry about that one, and I don't want you to worry about that one. Okay, and I'm going to give you the other two to try. Okay, so let's do those. Let's see what you guys do. And then again, when you're done, just pop done into the chat. Yes, Mihlali, you would. Okay, so remember, if you've got dx notation, you write the derivative just using an equal sign, just like Amahle said. Okay. No problem. Both, Palesa. Try and do both. Cool, Leanne. Well done. I'm going to move on now. Good job, everybody. There's a whole lot of you that are finished already. Good. Cool. Well done. These ones in the beginning are nice and easy to get us into the swing of things. Well done. All right. So who's feeling brave and wants to do question L for us? Who's feeling brave and wants to unmute and tell us what to do for L? Anybody? William, go for it, William.
My answer is 2 over 5 times x.
Okay, so that's fine. So you had 2 over 5. Sorry, Yeah, 2 over 5 x to the power of 1. Is that correct?
Yes, ma'am.
Okay. All right. Perfect. So what you could have done here if you wanted to, William, is you could have included this and just written it as 1 over 5 x to the power of 2, and then you would have ended up with exactly the answer you gave me. So that's fine. Not a problem. Who's brave? Well done, William. Thank you so much. Who would like to do this one for us? Let's see who's got the hand up first. Okay, Caleb. Go for it, Caleb.
Ma'am, I got 5x to the power of 3.
So you got, sorry, say that again. 5x to the
5,
power of?
3
Yes.
plus 5 over 4.
Okay, now hang on a second. I'm glad you said that. Okay. So when you are taking the derivative of a constant, the derivative of a constant is always equal to 0. Okay, so derivative of a constant always equals 0. So this was ready to be differentiated because each term was written sign number variable. Okay, so here we had to write p prime x, multiply our exponent with our coefficient. So 5 over 4 times 4 gives us 5, and then take away 1 from our exponent. The plus 5 over 4 becomes 0. Okay. Amahle, do we have to show the... No, you don't. You don't, Amahle. I was just writing it there, but absolutely you don't have to write it there. Okay, so I was just putting it there to show that we've taken away 1. Okay, but not necessary to write. Linda, the variable was in the numerator. So you don't have a negative exponent because it was x squared in the numerator. So it's positive 2 times positive 1 over 5. Okay, so it's different, for example, to those were all positive, but it would be different to something like this. Here you had your x cubed in the denominator. That's why you had to take it to the numerator and change the sign. So now when you multiply your exponent and your coefficient together, you're going to get a negative because a positive multiplied by a negative is a negative. Okay, so here, where was it? Okay, it was x squared in the numerator. Okay. All right. Where are the rest of my questions? I don't know where they've gone. Okay, all right, never mind. We'll make a plan. Okay. Now, what if they gave us something like this? Lebogang, let's see what your question is. Which one would have to be 15? Where do you see the 15? I don't see, Lebogang, I'm just struggling to understand what you're asking me.
I think Lebogang just gave a function and Lebogang derived the function.
Oh, okay. All right.
I'm not sure if that's what he did, but it looks like he has 5x to the power 3
Okay.
and
Yeah,
he gave
absolutely.
it 15x to the power 3.
Yeah. Okay, so if you derived 5x cubed, it would become 15x squared. Yes. Okay. All right. So then what they do is they start giving you functions that have got more than one term in them. All right. So what you would be doing is you'd be applying the power rule to every single term. So let's just talk a little bit more about what would happen here. Okay. So Ayanda's already got an answer. Okay. So Ayanda, did you write it as dy over dx? Because every single term is written sign number variable. Okay, so let's just see who's got a hand up. Amatle, do you want to do this one for us?
I just want to ask a question, ma'am.
Sure, of course.
When we're writing the final answer out, does it have to go in ascending order in terms of the powers?
No, definitely not. Doesn't matter. Okay, you don't have to worry about that at all.
Okay, thank you.
Okay, no problem. No problem. Okay, so Mikhail has offered an answer here. Well done, Mikhail. That is the correct answer. Good job. Okay, Caleb, do you want to tell us what you wrote?
I got dy over dx equals 12x to the power of 3 minus 35x to the power of 4.
Fantastic. Okay, good job. Well done. There we go. Excellent. Okay. So now that we've seen it with more than one term, okay, let's go and introduce some other pieces. Okay, so let's change our notation and let's write f of x equals. Okay, so now here, I'm just going to make this slightly more difficult. What happens if we had something like this? Okay, what if they expected us to do that? Okay, so remember, the derivative of any constant is 0. The derivative of any constant is 0. Okay, so that plus 2 would become a 0 when we derive. Okay, so what would we do here? Somebody had a hand up. There we go. Leanne, would you like to do this one for us?
Yes, ma'am.
Go for it. What do you think I should write?
So, ma'am, before we find the derivative, we have to change the fraction and the square root. So we'll have f of x is equal to 3x to the exponent negative 4.
Good.
X to the exponent half.
Lovely. Well done. Okay. Now on your next line, what are you going to write, Leanne?
Then next, ma'am, we're going to write f prime x equals to 3 times negative 4 to the power negative 4 minus 1.
Lovely.
And then negative 2 times half x to the exponent half minus 1.
Good. Well done. And now when you simplify all of that, what would you end up with?
Would end up with negative 12 x to the exponent negative 5.
Mm-hmm.
And then x to the minus x to the exponent negative half.
Well done. Excellent. Brilliant, brilliant, brilliant. Okay, very, very nice. Good work, everybody. Okay, let's make something just a little bit more difficult now. Okay, so third question. Okay, what if they gave us something like that? What would we do here? Anybody want to try this one? Go for it, Leanne. What would we write?
So ma'am, we can't find the derivative as yet since we have fractions.
Mm-hmm.
So first we're gonna write d of x into -4 x half, negative half.
Good.
Plus 3x to the exponent -2.
Good.
And then closed brackets. And
Okay,
because
and then minus
7 is constant.
Okay. Okay, but you've got to keep it there until you take your derivative. Keep going. You're doing very well. Lovely. Keep going.
Yeah. And then we'll have -4 times -half.
Okay, what's going to happen to your notation now?
Ma'am, we are going to look for the derivative.
Okay, so you're going to drop your dx and you're going to drop your square brackets. Okay, because you're taking your derivative. Good. Okay, keep going.
Then we're going to have -4 times -half x to the exponent -half minus 1.
Good.
And then ma'am will continue and say plus 3 times -2 to the x to the exponent -2 minus 1.
Lovely.
And 0 is -7 is a constant, so it's 0.
Beautiful. Okay, now just tidy all of this up. You're doing really well.
Then ma'am, -4 times half will be 2x and then -1 minus half will be -3/2. So it's 2 exponent -3/2. And then it will be plus a negative -6 x to the exponent -3.
Beautiful. Okay, lovely, lovely, lovely. Well done. Okay, very nice work. Okay, so you are going to get marks for removing the divide lines and writing exponents in the numerator. Okay, so there would be a mark for doing that. I don't know whether there would be a separate mark on this one, but there would definitely be a mark on this one where you've removed the root and written it with a negative exponent. Okay, and then when it gets marked matrix, what they would do is that they mark you accuracy marks on these. So remember, you're not going to get that accuracy mark. It has to be sign, number, variable. That has to be correct. Okay. All right. And then again, just be aware of your notation. When you are removing divide lines, brackets, and roots, you are not taking the derivative. Okay. You are preparing your statement for differentiation. Okay, you are preparing the statement for differentiation. You're not actually taking the derivative. So when you write dy over dx or f prime x, or you drop your dx in your square brackets, that's when you are applying your power rule. Okay, well done, everybody. That was great. Caleb, do you have a question?
Ma'am, for this
Yes.
third equation here,
Yeah.
if there's ever the square root of x, will that always equal
Yes.
half? Oh, okay, I was confused. Sorry.
Yes, absolutely. So in other words, if you have got the square root of x, the 1 is invisible and the 2 is invisible. So that's always going to be x to the power of 1 over 2. Okay, if you had root, and let's say you had the 4th root of x to the power of 7, the guy at the bottom gets kicked to the outside of the party. Okay, so that's going to be x to the power of 7 over 4. That's how you would get rid of your radicals. Okay. All right. There we go.